All right, we're going to talk about an application of exponential functions, and one of those is compound interest. Compound interest is something that is used in investing and banking and things like that. And so when we talk about figuring out what an investment might be worth over a period of time, we will use different equations that are exponential equations. So the two that we're going to focus on are here. And when interest is being compounded continuously, this is the equation that we use. When interest is being compounded n times per month, this is the equation that we use. And both of them have similar letters, so I'm just going to define the letters once, and it can be used for either one. So if you see a P, that's the first one, that is called the principal. And that is the initial amount that's invested. So if you put in $100 to start with, $100 would be the P. E is just E, that's not a variable, so we just keep that as E. It's a button on your calculator. R is your interest rate, and it's always written as a decimal. So if you get like 5%, you would use 0.05. T is time, and that is always measured in years. So if somebody gives you like, oh, how much would I have over after 6 months, you'd use 0.5 because you always measure it in years. There's another letter here, N. N is the number of times your money is compounded. It might be monthly, so then it's 12. I should say per year. If it's quarterly, that'd be 4 times per year, something like that. And the last one over here that I didn't really mention was A. And A would be the amount of money you have. So the amount of money after T years. So if I ask you, you know, how much money is there after 5 years? If you plug in 5 for T, whatever number comes out as your answer for A, that is the amount of money after that many years. So we'll just do one example here, and it says you have $12,000 being invested at an annual interest rate of 9%. Find the balance after 5 years, and then we have different compounded amounts. So we'll start with A, and if it's compounded quarterly, quarterly would be this second one, not continuously. Quarterly would be 4 times per, this should have been, I'm sorry, when interest is being compounded n times per year. I was thinking of monthly and I wrote month, but it's the number of times per year. So here quarterly is 4 times per year, and that means 4 would be your n. Okay, so what I'm going to do is take the principal, which is 12,000, and then my 1 plus, my interest rate is 9%. We'll divide by n, which we decided was 4, and the exponent is t times 4, which would be 5 times 4. So what I'd like you to do is practice typing all of that in your calculator and see what you get. You should get the same answer that I'm getting, or else you are typing it in your calculator wrong and it is doing a wrong order of operations for you. But you should get $18,726.11. For B, it's monthly. Monthly is 12 times per year, so N would be 12. So everything's going to stay the same. It's just where I have 4s, I'll replace them with 12s. And if you type all that in again, you should be able to get the same number as me if you're typing it incorrectly, and it is $18,788.17. If you notice, it's not a drastically larger amount, but it is slightly bigger because you're compounding a few more times in a year, so it works in your favor. Last is continuously, and continuously means we have to use this top equation, which we call the PERT equation. And P is still 12,000, E is E, and it's to the R, so 0.09 times T. So plugging all this in your calculator, you should have an E button on your calculator. Continuously gets you even more money, just slightly, but just a little more money in the end.